Hi guys, welcome to our video lecture series of Laplace transforms. So from our previous lecture we have started to discuss about the inverse transforms, and we took some examples and take their inverse transform. So we'll continue our lesson and we will solve some problems. So let's say that we have to take the inverse transform of 1 divided by s squared plus 25. Now if we look into this problem from here, we can see that it's the form of like sine t. When we take the transform of sine a t, what we get is a over s squared plus a squared. So if we compare this one with this, so we can say that it is similar, and just we have to make some manipulations like the a, just compare this a squared with this 25, so we can say that a is equals to 5. So here in the numerator a is missing, and if I multiply it by a, so I have to divide it by a similarly. And now I can write this problem as 1 over 5 Laplace inverse of 5 over s squared plus 25. So now this has become the Laplace transform of sine 5t. So my final answer will be 1 over 5 Laplace inverse of 5 over s squared plus 25. So the final answer will be 1 over 5 sine 5t. So this is the final answer, and the Laplace inverse of 1 over s squared plus 25 is just equals to 1 over 5 sine of 5t. That's our answer. Let's take another example. So let's have another question, and just we have to find the Laplace inverse transform of s plus 2 divided by s plus 2 squared minus 25. So now we have to take the transform of this function, and we can compare this function with the Laplace transform of hyperbolic cos hyperbolic t. So the Laplace transform of cos hyperbolic at is just equals to s over s squared minus a squared. So now we can compare this with this, and we can see that here is s plus 2 and here is s. So it's the change of scale property. We will use change of scale property here, that s is changing to s plus 2. So what does it mean? That it means that here with cos hyperbolic at, the function of e raised to the power negative 2t is multiplied with cos hyperbolic at. So now we can see that it is because of this s plus 2, we can see that the function cos hyperbolic at, this function is just multiplied by e raised to the power negative 2t. And now we want to find this a, so we will compare a squared with 25, and we can get a squared is equals to 25. That implies that a is equals to 5. So now we are very near to our solution, and we can say that the Laplace inverse transform of s plus 2 divided by s plus 2 whole squared minus 25 is just equals to e raised to the power negative 2t cos hyperbolic 5t. So that is the final answer of this problem. So if you recall, what we do in this problem is that first of all we compare the question we saw that here in the denominator it was s plus 2 whole squared minus 25. So and in the numerator it was s plus 2. So the function of s in the numerator and the function of s in the denominator. So we know that from our previous lectures, Laplace transform of cos hyperbolic at is equals to s over s squared minus a squared. So when we compare this with the question, and by applying change of scale property here, we saw that it was a function of cos hyperbolic at multiplied by e raised to the power negative 2t because of this 2 here. So we further solve the problem and we get to the solution e raised to the power negative 2t cos hyperbolic 2t. So let's take one more example. Let's say that we have to find the Laplace inverse transform of this function 1 divided by s plus 3 squared minus 4. So now in the similar manner we will look at the denominator, and we can see here that is likely a function of sine hyperbolic at. If we find the Laplace transform of sine hyperbolic at, what we will get is 1 over s squared minus a squared. So now I can compare this with this question, and also we will use change of scale property, that is as is changing from s to s plus 3, and because of this 3 we can say that this in this problem e raised to the power negative 3t is multiplied by the function of sine hyperbolic at. Now we have to find a, so we can compare this a squared with 4, so that implies that a is equals to 2. So now we are near to the solution, and the Laplace inverse of s1 over s plus 3 squared minus 4, that will be equals to, now for this a, sorry, here I forget to write a because it's a over s squared minus a, so I need a here. So a is 2, so I multiplied by 2 in the numerator, so I will multiply it by 2 in the denominator as well. So it will be 1 over 2 Laplace inverse transform 1 over 2 multiplied by 2 over s plus 3 squared minus 4. So the final answer will be equals to 1 over 2 e raised to the power negative 3t sine of hyperbolic 2t. So that is our final answer. So thank you guys